Hi class, I am teacher Ray and I am about to deliver the part D of the lesson plan, which is the lesson proper. Pythagorean Theorem. This theorem was composed by Pythagoras, who lived between 580 to 500 BC. So in mathematics, the Pythagorean theorem or Pythagoras theorem is a fundamental relation in geometry among the three sides of a right triangle. It states that the area of the square of sides of the hypotenuse is equal to the sum of the areas of the squares of the two sides. This theorem can be written as the equation relating to the lengths of the legs A, B, and the hypotenuse C, often called the Pythagorean theorem. So the general formula of Pythagorean theorem is c squared equals a squared plus b squared. But many evidence says that Pythagorean theory was used long before the birth of Pythagoras. So it was used in Babylonian time, which is the Plimpton 322 tablet. Babylonians used this thousands years before the birth of Pythagoras. And also the geometric proof of Pythagorean theorem by Zhu He Xuanjing from China. And of course, the pyramid. I think they cannot build pyramid without the Pythagorean theorem, because this structure was full of squares and right angles and triangles. So we can only use Pythagorean theorem on right triangles. Remember that, students? Remember. So let us recap on how we identify the right triangles. So given the 9 triangles, let's see and recap to identify which are the right triangles. Is triangle 1 a right triangle? No. Is triangle 2 a right triangle? Yes, because it has a right angle, which is the 90 degrees. How about triangle 3? No. How about 4? No. And how about triangle 5? No. How about triangle 6? Yes, that's a right triangle. And triangle 7 also is a right triangle. Triangle 8 is not a right triangle, and 9 is also not. Okay? Did you see the pattern? So let's proceed. How can you state Pythagorean theorem? In order for us to understand, we must first identify the parts of the triangle. So this is triangle ABC with points A, B, and C, and side A, B, and C. So this one, we can identify this as right triangle because of point C, which is 90 degrees. So let us identify the parts. So from point A to point B, which is called side C, that's what we call the hypotenuse, line AB, or the hypotenuse. Remember, the hypotenuse is always opposite of the right angle. How about side AC? Side AC or line C or line B is what you call line AC, leg B. And how about from point B to C? It is called line BC or leg A. So according to the theorem, the general formula of Pythagorean theorem is c squared equals a squared plus b squared, where c is the length of the hypotenuse, and a is the length of the first leg, and b is the length of the second leg. So we can prove Pythagorean theorem is true by using proof of simplification. As you can see, this Pythagorean theorem is composed of a formula of squares, because if you multiply the side by its side, that will yield you to a square. So you would imagine an illustration or drawing like this. Given the example of triangles, given the lengths of A equals to 3 and B is equal to 4 and C is equal to 5. So let's visualize this by drawing small squares so that we can visualize more. So this is the given. So you see there's a side 3, 4, and 5. If we square 3, you will yield at a big square like this. 3 times 3 is equal to 9. 9 squares. Okay. If we square 4, it will yield to a big square with 14 squares. 4 times 4 is 16. So how about if we square 5? It will yield to a big square with 25 squares, small squares. Okay. So did you notice? But if you add the blue from the 4 side and the pink on the 3 side, you will if you add them, it will become the total of the square of the big side or the hypotenuse. So we can prove more Pythagorean theorem by derivation of Pythagorean theorem. So let us consider a square with a length a plus b. Each side of square is divided by two parts of length a and b. Now combining these 4 points will make another square with a length of say c. So we can imagine a shape like this. There's a big square with side a and b, and then the points are connected. Then we label the side as C of the small side square. So we can say that the area of the big square is equal to area of the small square plus the area of the small triangle. So the area of the big square is A plus B squared. As you can see and visualize this side is A plus B squared. So the area of the small square is C squared. That's the white square inside. And the area of the small triangles is 1/2 AB. 1/2 AB is the formula for triangle. But since there are 4 pieces, let's multiply it by 4. So by using the rules of polynomials, you will yield the a squared plus 2ab plus b squared equals to c squared plus, if you multiply 4 by 1/2, it will cost you 2, then AB. Since there's 2AB on both sides of the equation, we can cancel them out. So you will yield a squared plus b squared equals c squared, or by rearranging, c squared equals a squared plus b squared, which is the Pythagorean theorem. So let's have an example of what we have learned. First condition, missing hypotenuse. This green triangle has sides and legs of 6 and 8, but the hypotenuse is unknown. So first, let us write the general formula for Pythagorean theorem, which is c squared equals a squared plus b squared. And then substituting, the hypotenuse is x unknown equals 6 squared plus 8 squared. So by further yielding, we will get x squared equals 36 plus 64. By adding 36 and 64, it will cost you 100. And then we get the both sides. We will square the both sides, the square root, so we can get the x value of 10. So there's a second condition that one leg is missing. So let's write the general formula of the Pythagorean theorem, which is c squared equals a squared plus b squared. And then substituting, the hypotenuse c is the part which is 17 centimeter, and we will square, equals the side which is 15 centimeters squared plus the b squared, which is the unknown. So rearranging, b squared equals 17 squared minus 15 centimeters squared. So by further elaboration, we will yield at 289 centimeters squared minus 229 centimeters squared, 225. And then if we subtract 289 to 225, we will result to 64 centimeters squared. And we need to get the square root of both sides to get b, and then b is 8 centimeters. So I hope you learn about the Pythagorean theorem, and we can use it in many fields. And that's all. Thank you, and God bless. The next part is application and generalization, to be delivered by Ma'am Corina de la Peña.